What is an epoxy resin and how is it made? Hey, detailed engineering. Have you ever been amazed by those wooden tables with shiny resin rivers, floors with a mirror finish, or even fixed something with a super strong glue? You've probably come across epoxy resin before. It seems magical, transforming from a viscous liquid into a solid, durable material with an incredible shine. But how does this transformation happen? And what exactly is epoxy resin? Epoxy resin is at its core a type of thermosetting polymer. And what does that mean in simpler terms? Imagine that it's like a special kind of plastic, different from some plastics that can be melted and reshaped several times, like a polyethylene terephthalate bottle, which is thermoplastic. Epoxy resin, once it's cured, that is, once it's hardened, can no longer be melted or have its shape changed. With heat, it becomes a permanently rigid and strong material. The main characteristic of epoxy resin is that it usually comes in two separate liquid components, which, when mixed in the right proportion, react chemically and harden in a process we call curing. That's what gives it its impressive properties of strength, durability, and adhesion. But to understand how it works, we need to know what it's made of. So, what are the ingredients of this magic? For epoxy resin to form, we need two main ingredients that mix to create the final substance: the resin itself, also known as part A, and a hardener, also called part B or catalyst. Part A, the resin, is what we chemically call a prepolymer or oligomer. Epoxy. Most common epoxy resins are produced from the reaction between a substance called bisphenol A and epichlorohydrin. But don't worry about the complex names. The important thing here is to understand that this combination forms molecules that have epoxy groups at their ends. Think of these epoxy groups as arms or hooks that are waiting to connect with other molecules. It is this molecular structure that gives epoxy resin its ability to react and form a solid three-dimensional network. Without the second component, the resin would remain in a liquid state and would never fully harden. But if the resin alone doesn't harden, what makes it so strong? This is where the second crucial component comes in, the hardener or catalyst, part B. This is the agent that will activate the resin and make it harden. The most common hardeners for epoxy resins are chemical compounds known as polyamides or anhydrides. The function of these substances is to react with the epoxy groups present in the resin. Imagine that the resin has several hooks and the hardener has several eyes that fit perfectly together. When you mix the two in the correct proportion, these hooks and eyes start to bond, forming a complex and interconnected molecular network. This network is what gives the cured material its rigidity, chemical resistance, and mechanical strength. The mixing ratio between the resin and the hardener is absolutely crucial. If you add too much of one and too little of the other, the curing reaction will not occur, and the resin can become sticky, soft, and not reach its maximum strength. And how do these two liquids turn into such a solid and durable material? The hardening process of epoxy resin is a fascinating chemical reaction called polymerization, specifically an addition polymerization, or in some cases, ring opening polymerization. When the resin, or part A, and the hardener, or part B, are mixed, the molecules of the hardener start to attack the epoxy rings of the resin molecules. This opens those rings and allows new chemical bonds to form. These bonds are not simple, but create a complex three-dimensional network, like a super strong spider web that interlaces in all directions. That's the reason why cured epoxy resin is so rigid and strong. During this reaction, something very important happens: the release of heat. This process is exothermic, meaning it releases energy in the form of heat. You can even feel the mixing container getting warm. That's why if you mix a large amount of resin, it can get too hot and cure very quickly. Sometimes it even bubbles or cracks. The curing time is the time needed for the resin to reach its final hardness and properties. It can vary from minutes to hours, depending on the specific type of resin and hardener, the ambient temperature, and the amount mixed. Once this three-dimensional network is fully formed, the resin is cured and it can no longer be reverted to its previous state. Where exactly do we find epoxy resin in our daily lives? What are its main applications? The versatility of epoxy resin is one of its greatest advantages, which makes it indispensable in a wide range of industries. One of the most visible and aesthetically appealing applications is in the creation of artistic and decorative pieces, like the famous river tables, tables with resin rivers, jewelry, and coatings for countertops and floors. Its ability to be pigmented and to encapsulate objects opens up a world of creative possibilities. However, its applications go far beyond aesthetics. In the construction industry, epoxy resin is used as an adhesive for concrete, mortars, and in coatings for industrial and residential floors, offering high strength, abrasion resistance, chemical resistance, and impact resistance. Think of garages, factories, and hospitals. Many of these places use epoxy floors because of their durability and ease of cleaning. It is also essential in the manufacturing of composite materials, such as carbon fiber and fiberglass, serving as the glue that bonds and hardens the fibers to form lightweight and extremely strong parts used in airplanes, race cars, boats, and sports equipment. In electronics, epoxy resin is used to encapsulate sensitive components, protecting them against moisture, dust, and mechanical shocks, ensuring the durability of circuit boards and other devices. In addition, it is a powerful structural adhesive capable of bonding different materials with impressive strength. It is used in automotive repairs, aeronautical airports, and even in home projects. With such a versatile and strong material, is using epoxy resin safe and simple? Although epoxy resin is an amazing material, it's essential to use it with proper care and follow the manufacturer's recommendations. Because it is a chemical substance in its liquid form, it can cause irritation to the skin, eyes, and respiratory tract. That's why using personal protective equipment is crucial. Nitrile gloves, safety goggles, and in enclosed or poorly ventilated environments, an appropriate respirator mask are indispensable. Workplace ventilation is a very important factor for dispersing vapors that can be inhaled. In addition, the exact mixing ratio between the resin and the hardener is vital. Any mistake can compromise the quality of the curing, resulting in a sticky, brittle material or one that does not reach its maximum properties. Room temperature also influences the curing time, speeding it up on hot days and slowing it down on cold days. Therefore, always consult the product's technical data sheet and the manufacturer's instructions to ensure safe work with the expected result. If you've made it this far and enjoyed the video, take the opportunity to subscribe. If you're not subscribed, leave your like and activate the notification bell. And if you find our content interesting, consider becoming a member to help us keep producing content here on the platform and be remembered in our videos. And if you're curious to learn more about the courses we recommend, scan the QR code here on the side or check the link in the video description to have access to various opportunities to develop several skills that will make a difference in your career. So, have you ever had any experience with epoxy resin? Have you ever created something amazing or come across it in a product you didn't expect? Which application of epoxy resin surprises you the most? Leave it here in the comments, I want to know. Right here on the side, there are two interesting video options you need to watch to expand your knowledge and explore your curiosity. And if you want to support us, Leave your like, subscribe to the channel, turn on the notification bell, and consider becoming a channel member. That's it, engineering lovers. A big hug, and I'll see you in the next video.